Now we're going to talk about one-step inequalities. So an inequality is just like a less than or greater than. There's more than one x value that will satisfy for the solution. Couple things to remember is that if you divide or multiply both sides of an inequality by a negative number, you need to flip the inequality symbol in the middle. Also, if you have a greater than or equal to or less than or equal to, you're going to have a shaded circle, while less than or greater than just means an unshaded circle. If the equal to part, that means you could actually equal that value. If it's just the less than or greater than, that means you're going to get super, super, super close, but not actually equal it. If we look at number 1, I see x plus 4 is less than or equal to 8. Because that's addition, I'm going to do the opposite to move it to the other side. So I'm going to subtract 4 from both sides. Positive 4 minus 4 becomes 0. So I'm going to be left with x is less than or equal to 8 minus 4 is 4. X is all by itself, so I solved it. I'm never going to graph it. Sometimes you'll be given a number line, and other times you're going to kind of make your own. So I'm going to put 4, 5 is bigger, 3 is smaller. At 4, I'm going to have my circle. Because I have an equal to, it's going to be shaded. And then x is less than, it's smaller. 3 is smaller than 4, so I'm going to go to the left. If I take 4, I can plug it into my original equation. 4 plus 4 is less than or equal to 8. That's true. If I take 0, because that's less than 4, 0 plus 4 is less than or equal to 8. That's true. So anything to the left of 4 will make this a true inequality. If I pick something to the right, let's say I pick 5, 5 plus 4 is 9, which is bigger, not smaller, than 8. That's why we can't shade that part. For 2, I see x minus 3 is greater than negative 2. I need x by itself. I'm subtracting 3, so the opposite is add 3 to both sides. So x is greater than 1. I'm going to graph it. So I have 1, 2 is bigger, 0 is smaller. My circle goes at 1. It says x is greater than 1. So I need a number bigger than 1. 2 is bigger than 1. So I'm going to go right. Again, all my solutions are going to be where my arrow is. So there's lots and lots of numbers that would fulfill this inequality. If I take 2, 2 minus 3 is bigger than negative 2 because it's negative 1. If I take 1, though, 1 minus 3 is negative 2, and it says I can't equal it. I have to only be bigger than it. If I take 0, 0 minus 3 is negative 3, which is smaller, not bigger than negative 2. If I look at problem 3, I've got negative 4x greater than negative 20. You need to get x all by itself. So right now, the negative 4 and the x are being multiplied. Opposite multiplication is division. I'm dividing both sides by a negative number, so I'm going to flip my inequality symbol. And negative 20 divided by negative 4 is 5. I'm going to have 5, 6 is bigger than 5, 4 is less than 5. I'm going to have an open circle at 5 because it's just less than. Because x is less than, 4 is less than 5, so I'm going to go to the left. Again, I can check it. If I put 4 in, I'm going to get 4 times negative 4 is negative 16, which is bigger than negative 20. But if I put 6 in, 6 times negative 4 is negative 24, which is smaller than negative 20. When I look at 4, I've got x divided by negative 6 is less than or equal to negative 9. Since this is division, my inverse or opposite operation would be multiplication. I'm going to multiply both sides by negative 6. We have x. Because I'm multiplying both sides by negative 6, I flip my inequality symbol. It's greater than or equal to positive 54. 55 is bigger than 54, and 53 is smaller. And we have a closed or shaded-in circle at 54. X is greater. 55 is greater than 54, so I'm going to the right. $54 and anything bigger than 54 would make this inequality a true statement if I plugged it in.